If your application requires measurement of a widely diverging beam, an integrating sphere might be the right solution. An integrating sphere is an optical component that captures a light beam and enables you to measure the power in the beam under conditions that would otherwise be very challenging. For example, a widely diverging beam that might overfill a regular sensor's aperture. Here's the basic idea. The inner surface of the sphere is coated with a highly diffuse white coating. The beam enters the sphere through an opening, and because the inner surface is so highly diffuse, the light is reflected multiple times in all directions. This causes the light to be uniformly distributed around the entire inner surface of the sphere. You can think of it as a diffuser, but in 3 dimensions. There are many design details that need to be optimized for various applications, including the size of the sphere, the type of detector used, placing of internal baffles to prevent direct illumination of the detector by the source, a necessary condition for the integrating sphere sensor to operate properly. Because of the uniform distribution of the light inside the sphere, we can use a power sensor to sample a small part of the sphere's inner surface and measure the power there. Knowing the area of the sensor and the surface area of the sphere, we can automatically apply a calibration factor to get the total power in the sphere. Because this optical trick makes the readings independent of beam size, position, and divergence, we can use an integrating sphere to measure power from sources whose beams are widely diverging, such as LEDs, VCSELs, and other laser diodes, fiber optics, lamps. Parallel laser beams can also be measured, taking advantage of the fact that the integrating sphere effectively attenuates the beam by having only a small fraction of it reach the sensor. For example, we can make use of the fast response of a photodiode sensor and measure powers that, if directly incident on the photodiode, would saturate it. Also, the sphere is essentially insensitive to misalignment of the beam. Most integrating spheres also have extra ports from which light can be sampled for other uses, for example, to perform spectral measurement or analyze temporal pulse shape in parallel to the power measurement. Integrating spheres can also be used to measure transmittance or reflectance of diffuse or scattering materials. The test sample would be placed at the entrance port of the sphere or at a port opposite the entrance port, depending on the details of what's being measured. We can also use the sphere in the reverse direction. Instead of using it as a collecting device for capturing and measuring a beam, the open port of an internally illuminated integrating sphere can itself be used as a large area diffuse light source. Ophir offers a number of different integrating sphere measurement solutions, both with and without integrated sensors. For fiber optic and other small sources, there's the IS-12W, a 1-inch sphere with 5 mm aperture diameter and a silicon detector, and the 3AIS series. These are 1.5-inch diameter spheres with a 12 mm aperture. These can be set up for free space input or fiber input using a suitable fiber optic adapter. There's a 3AIS model for 420 to 1100 nanometers using a silicon detector, and a model for 800 to 1700 nanometers using an InGaAs detector. The 3AIS also has an additional port for sampling light out to additional measurement instruments. For applications that need a larger sphere, there's the IS6 family of 5.3-inch integrating spheres. These have a 63.5 mm aperture for divergent beams and a 25 mm aperture for collimated beams, as well as an additional North Pole port for a fiber adapter to pick off a small part of the light for any other measurements you might need to perform. They're available with various detector types for the UV, visible, and near IR spectral ranges, and for powers up to 30 watts depending on the model, as well as IS6 integrating spheres without any detectors, just the various ports, which you can use for whatever your application requires. For more information, contact Ophir directly or through our local representatives, or visit our website.